Hello everyone, welcome back to my channel. I am Bhavani, first year CSC student at Sri Venkateshwara College of Engineering, Bangalore. Today I am here with a new video about corrosion. The contents are: what is corrosion, types of corrosion, corrosion prevention methods, conclusion. Firstly, we're going to discuss what is corrosion. Corrosion can be defined as the destruction or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. Example: rusting of iron, the reddish brown scale formation on iron object. Fe2 plus 2H2O minus give rise to FeOH2. 4FeOH2 plus O2 plus 2H2O give rise to Fe2O3. 3H2O hydrated ferric oxide rust. Dry corrosion. It is also called as chemical corrosion. Dry corrosion involves the direct attack of metals by dry gases, mainly through chemical reactions. Example: the attack of dry air or oxygen on a metal to form an oxide layer over the surface. Wet corrosion. It is also known as electrochemical corrosion. Wet corrosion involves reaction in aqueous solution medium. The conducting surface of the metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. Example: rusting of iron. Wet corrosion is explained on the basis of electrochemical theory. Types of corrosion. Firstly, differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in direct contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode, undergoes oxidation, and gets corroded, and the other metal with higher electrode potential acts as cathode, undergo reduction, and protected from corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. Example: when iron is in contact with copper, iron becomes anodic and undergoes corrosion, whereas copper becomes cathodic and remains unaffected. Tin coating, copper vessels, steel pipe connected to copper plumbing, bolt and nut made of different metals. Differential aeration corrosion. When a metal is exposed to different concentration of air or oxygen, part of a metal exposed to lower concentration of oxygen becomes anodic and undergoes corrosion, whereas other part of metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. Example: iron rod partially immersed in NaCl solution, part of metal immersed solution is exposed to lower concentration of oxygen, becomes anodic and undergoes corrosion, whereas part of metal outside NaCl solution is exposed to more oxygen, becomes cathodic and remains unaffected. Typically, examples of differential aeration corrosion are the waterline corrosion and pitting corrosion. Waterline corrosion. It is observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time, the inner portion of the tank below the water line is exposed only to dissolved oxygen, whereas the portion above the water line is exposed to more oxygen. Thus, the portion below the water line acts as anode and undergoes corrosion. The upper portion acts as cathode and is unaffected. Pitting corrosion. This type of corrosion is observed when dust particle or oil drops deposited over the metal surface. Pitting corrosion results when the portion of a metal covered by dust, which is less aerated, becomes anodic and undergoes corrosion. Form pit. The remaining area of the metal, which is exposed to higher concentration of oxygen, becomes cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases because formation of a small anodic area to corrode faster because accepting electrons from the cathodic area increases. Corrosion prevention methods. Here are a number of ways to protect the metals from corrosion. Here we will discuss some of the most commonly used methods. Firstly, by surface coating. You can prevent the corrosion of the metal by coating the surface using any of the following: by applying oil, grease, paint, or varnish on the surface, by coating, depositing a thin layer of any other metal which does not corrode, by connecting metal to a more electropositive metal. You can also prevent by connecting the metal to a more electropositive metal. As long as the more electropositive metal is present, the given metal will not get corroded. By forming insoluble phosphate or chromatic coating. The third method of preventing is by treating the metal surface with phosphoric acid. It forms an insoluble phosphate coating on the surface which protects the metal from corrosion. Lastly, we're going to conclude that corrosion is a complex and ongoing challenge that requires a multifaceted approach involving research, prevention, maintenance, and public awareness to mitigate its impact on materials, structures, and the environment. Thank you for watching my video. Please like, share, and subscribe.